Hello students, in this session you will learn about the different number systems, how data is represented in different kind of number systems, and you will also learn how to convert a number of one number system to another number system. First we'll get to know the different kinds of number systems and how the sequencing of numbers is being done in each number system. First of all, the very familiar decimal number system which we regularly use in our day-to-day life, whenever you do mathematics, we always use the decimal number system. The decimal number system is made of 10 digits. That's why we say decimal number system, which has numbers from 0 to 9. So how do we proceed writing numbers in a decimal number system? It's very familiar to all of you. We write numbers starting from 0. In this case, we'll write 0 to number 9. So once number 9, we reach the maximum limit in a digit, we move on to the second digit, that is 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5 and so on till 1, 9. Now we have reached the maximum here. So we'll proceed to 2 now. After 1 comes 2. 2, 0, 2, 1, 2, 2, 2, 3, 2, 4 and so on till 2, 9. Again we have reached the maximum number with 2. Then we'll proceed to 3. 3, 0, 3, 1. 3, 2, 3, 3, that is 34, 35, 36 and so on up to 39. Then we proceed from 40 to 49, then 50 to 59. This is how the number system goes, and at one point when we reach 99, that is 99, we go to the third digit, that is 1, then 0, 0. Because both the digits have reached the maximum number. So the next number should be the third digit. So starting from 1, again 0, 0, 0, 1, 2, 3, so 4 and so on till we reach 999. Then we go on to the fourth digit followed by 3 zeros and again 1001, 1002 and so on. So this is how we write numbers in the decimal number system. And any number which is written in a particular number system, say for example 39, if it belongs to decimal number system, we indicate it with the help of a radix. Radix is a number that is written in the base of a number. But generally, we won't mention the radix in case of a decimal number system, because any number which is generally written without a radix is considered as a decimal number system. Only for binary, octal and hexadecimal, it is a must that you put the radix here. For decimal number system, this is not mandatory. Any number, see for example 459, 742, 1 lakh and 523. Any number that is written without a radix is considered as a decimal number. So you need not mention the radix, that is the base in the number. Now moving on to binary number system. Binary number system consists of only 2 digits. Bi means 2. 2 digits, which is 0 and 1. Now how do you write the sequence of numbers in a binary number system? The first digit is 0, second digit is 1, that's all. The numbers get over. So we move on to the second digit, which is 1, 0, 1, 1. Now we've reached the maximum in both the digits. So we'll move on to the third digit, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Now the maximum number is 1 in the binary number system. We have reached the maximum in all the 3 digits. So we write the fourth digit now. 1, 000, 1, 0, 0, 1, 1, 0, 1, 0. Like this we move on. This is how you write numbers in decimal number system 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up to 100. Same way, this is how you proceed to write numbers in the binary number system. Right? So once you reach 4 ones, we reach the maximum in all the 4 digits, then we'll go for the fifth digit and fill the remaining numbers with zeros and proceed like this. This is how it proceeds in the binary number system. Now, any number that is written in the binary number system is given a base 2, that is radix of the number 10101. Suppose if this is a binary number, you should mention the radix as 2. Suppose you don't mention the radix, then this is considered as a decimal number system, that is 10,101. Even if you don't put this 10, that's okay. Any number without radix is considered as a decimal number system. But when you give the radix as 2, it means it's a number that belongs to the binary number system. Okay. Next we move on to octal number system. Octal number system has numbers 0 to 7, that is totally 8 digits. 0 to 7. Now how do you write numbers in the octal number system? Start with 0, 1, 2, 3, 4, 5, 6, 7. Now I told you the numbers stop with 7. We don't have digit 8 and 9 in the octal number system. So after 7 is reached, then we go on to the second digit starting with 1, 0. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7. Now 7 is the maximum number. So with 1 we have got 7. So now start with 2. 2, 0, 2, 1, 2, 2, 2, 3. You shouldn't mention this as 23 because 20 is a number that belongs to decimal number system. Tens. So 23 means 2 tens and 3 ones which belongs to decimal number. So you shouldn't say 23. It is 2, 3. 2, 4, 2, 5, 2, 6, 2, 7. So we cannot go beyond 7. So start with 3, 0, 3, 1, 3, 2, 3, 3, 3, 4. Now if you listen carefully, you only have numbers up to 7. So 8, 9, 18, 19, 28, 29, 38, 39. These numbers will be missing here in the octal number system. Right? So at one point, 7, 7 will be there. So 7, 7 is the biggest 2-digit number in octal number system because we don't have 78, 88, 99. These numbers are not present. So once we reach 7, 7, we should move on to the third digit 100. Whereas in the decimal number system, after 99 comes 100. But here after 7, 7, we get 100, 101. You should not call this as 100. It's 100. 101, 102, 103, 107 and then 110. It goes on like this. So if you skip 8 and 9, you will get octal number system. Why should we learn this? Because in the textbook you have a question, fill in the sequence of octal numbers. Fill in the sequence of octal numbers. Say for example, 43, 44, 45. Now fill in the sequence. How do you fill in? It is followed by 46. You shouldn't say 46. 46, 4, 7. Once you reach 7, you shouldn't write 4, 8. So 5, 0, 5, 1 and so on. This is how you have to fill in the sequence of octal numbers. Now, let us see how to write hexadecimal numbers. And same way, when you write an octal number, say 2, 3, 7, it should be written to the base 8. 8 is the radix for octal number system. Then comes hexadecimal number system. Hexadecimal number system has 16 digits. Now, we know only 10 numbers, 0 to 9. We don't have 16 unique numbers. So, for that purpose, we use alphabets also. So, how do you write a sequence of numbers in hexadecimal number system? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. After 9 comes A, B, C, D, E, F. Now consider this A to F also as a digit. Then you will know how to write 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6 up to 1, 9. Then 1 A, 1 B, 1 C up to 1 F. Now F is the maximum digit. So this digit up to 1, the pairing of 1 and the maximum has reached. So now I move on to 2, 0, 2, 1. 2, 2, 2, 3 up to 2F. Then 3031 up to 3F, and one point we will have FF, right? Now at one point you will have 9F, then comes A0, A1, A2, A3 up to AF, then B0, B1, B2, B3. At one point we will have F0, F1, F2, F3 and so on up to FF. So this is the maximum, that is the biggest, greatest 2-digit number in the hexadecimal number system. After this we will have 100, 101, 102 up to 10F. Then it goes on like this. Right? So this is how you fill in a sequence of numbers using the decimal number system. So next we will learn how to convert a number that belongs to one number system to another number system. Any given number can be converted. An hexadecimal number you can convert to binary. Decimal you can convert to octal. So we will learn the method which is used to convert one number system to another number system. So now we will learn the binary system to octal conversion, binary to hexadecimal conversion, because this will be the simplest of all conversions. So anything that doesn't involve decimal number conversion is very simple. So we can learn octal to binary, binary to hexa, hexa to octal and vice versa. Okay. So before we get into these three kind of number system conversions, you should first know to write this tabular column. If you write this tabular column, then this is going to be very simple. Now how to write this tabular column? The first one involves octal to binary conversion tabular column. How to write this? First, write the octal numbers 0, 1, 2, 3, 4, 5, 6, 7. 8 octal numbers. Now you'll have to write the binary equivalent of this. Now you should write the binary numbers in sequence, and whenever you refer to octal, you have to write in 3 bits, 3 numbers. It's in the form of 3 bits each. So to fill in this, you can have a shortcut method. You have to put 4 zeros, then 4 ones, then 2 zeros, 2 ones, 2 zeros, 2 ones. Then a 0 and a 1, 0 and a 1 and so on. So the binary equivalent of 7 is 111. Binary equivalent of 4 is 100. Binary equivalent of 1 is 001. When you talk about octal number system, you will have to do the binary conversion in the form of 3 bits. Okay, so that I have given in this tabular column. Now the same, how will you fill in using the binary numbers in hexadecimal number system? In order to do the hexadecimal number system, we need to do the conversion for 16 digits, because hexadecimal number system contains 16 numbers. So 0 to F, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Now, to do this binary conversion for hexa, you have to fill in the numbers in 4 bits. Okay, so 4 bits form. How do you do this? For that, you do 8 zeros, 5, 6, 7, 8 zeros, then 8 ones, then 4 zeros, 4 ones, then 4 zeros, 4 ones. Then 2 zeros, 2 ones, 2 0, 2 ones, 2 zeros, 2 ones and so on. Then 0 1, 0 1, 0 1. Fill in the tabular column this way. It's very easy to do the conversion. Now when you talk about number 5, the hexadecimal equivalent is 0 1, 0 1. When you take B, it's 1 0 1 1. For letter E, it's 1 1 1 0. So I have given that tabular column here. With the help of this tabular column, we will now see how to convert a number system to another for these 3 number systems. So we'll see an example of how to convert an octal number to binary. say for example, you have number 346 to the base 8. So we need to convert this to binary. Now I told you should have the tabular column ready for this kind of conversion. Now first check number 3 in this table. It is 0, 1, 1. So 0, 1, 1. For number 4 it is 1, 0, 0. And for number 6 it is 1, 1, 0. So the answer is, you can skip this 0, doesn't have a value. So 1, 1, 1, 0, 0, 1, 1, 0 to the base 2. Suppose you have a decimal number, you have a dot followed by 2 numbers. Then 0, 1, 1, 1, 0, 0, 1, 1, 0 dot. The equivalent of 2 is 0, 1, 0. Equivalent of 3 is 0, 1, 1 to the base 2. So very simple. Just take the binary equivalent from the tabular column and keep writing. If you have a decimal point here, follow that in the same place. Okay. So this is how you convert octal to binary. Now how to convert a number from binary to octal? Again, it's very simple. Suppose you have a number like this to the base 2. Now convert this binary number to octal number system. Now always start in this direction from the least significant bit. This is called the least significant bit and this is called the most significant bit. That is the bit with the least weight. Here this one has the most weight. That is the place value. Okay. And divide this, start from the least significant bit and divide this into three parts. This way, 1, 2, 3, cut it, 1, 2, 3, 1, 2, 3, divided this way. Now, what is the equivalent of this 1, 0, 1 in the tabular column? 5. What is 0, 1, 0? 2. What is 0, 0, 1? 1. What is 1, 1? That is 0, 1, 1, which is 3. So, the octal equivalent of this number is 3125 to the base 8. So, both octal to binary and binary to octal is worked out with the help of this tabular column. So, whatever it is from this way to this way or from this to this, you have to refer to this tabular column and do the conversion. Now, let us move on to hexadecimal to binary. This is again very simple. Say for example, you have 8A4 to the base 16. How to convert this into binary? What is the number for 4 in this tabular column? 0, 1, 0, 0. What is the equivalent of A? 1, 0, 1, 0. What is the equivalent of 8? 1, 0, 0. So, this is the binary equivalent of the given hexadecimal number. Suppose you have dot A3 or D3. So, you will continue with a dot. What is the equivalent of D? 1, 1, 0, 1. What is the equivalent of 3? 0, 0, 1, 1 to the base 2. So, this is the binary equivalent of the given hexadecimal number. Any hexadecimal number, refer to the tabular column and take the equivalent of the binary. Now, how to convert a binary number to hexadecimal? If you want to convert a binary number, say for example, this is the binary number. You want to convert this into hexadecimal. Now, how did you do it for octal numbers? You divide it into three parts. But here, you all know that I already told you, if you want to have a binary equivalent, you should give it in 4 bits. So, in this direction, divide the number into 4 bits. Now, check the tabular column. 1001 is the equivalent of what? Number 9. So, this is equivalent to number 9. And what is 101 stand for? Number 5. 1010 stands for A. 1 alone means this one. Right? That is 000, which means there are no numbers here. You can fill it with zeros, which means it's 1. So, the hexadecimal equivalent of the given binary number is 1859 to the base 16. Suppose you have a dot here, 1 0 1 0 1 1. Now how do you divide this? Now from the dot you have to move in this direction. So 1 2 3 4, cut it. So 1 0 1 0's equivalent is A, 1 1 is 1 1 stands for 1 1 0 0, which means C. Okay, so this is how it goes. Now we'll see how to convert octal to hexadecimal, not to binary. So suppose you have number 375, which is an octal number, you need to convert it to hexadecimal. Now to do this conversion, you just have to follow an intermediate step. First convert this to binary and then convert that binary to hexadecimal. So converting this to binary is very simple. We all know how to do this. Take the tabular column. What is the equivalent for 3? 0, 1, 1. What is the equivalent of 7? 111. What is the equivalent of 5? 1, 0, 1. So this is the binary equivalent. Now convert this binary equivalent to hexadecimal. How will you do this? I have already told you, whenever you have a binary number, when you do it to hexa, you have to convert it into 4 bits. So divide this into 4 bits. So 1101, refer to this tabular column, stands for D. 1111 stands for F. So 375 to the base 8 is equal to FD to the base 16. So whenever you convert octal to hexadecimal, first convert to binary and then to hexa. Same way, you have number A58 to the base 16. You need to convert this into octal. How will you do this? First refer to the hexa table and take the binary equivalent. A stands for 1010, 5 stands for 0101 and 8 stands for 1000. So this is the binary equivalent, and binary to octal should be this way. So divide it into 3's because we are going to refer to octal table. So divide it into 3 parts. So you can refer it to it easily. 101 stands for 5, 001 for 1, 011 is 3 and 000 is 0. So this is how you convert hexadecimal to octal. So there is one intermediate step where you convert it to binary and then go to octal. So any kind of conversion from octal to binary or binary to hexa or hexa to octal, first you need to refer to these two tables, and remember, whenever you convert octal to binary, use 3 bits, hexa to binary, use 4 bits each. So next we will move on to decimal to the other 3 number systems. That is quite a bit different. We'll see how to do it. Now we'll move on to decimal to other number systems conversion. So how to convert a number which is in decimal form to binary. The same method will be followed for octal and hexadecimal. So when you want to convert a decimal number, say for example 59 should be converted to binary. Now this 59 is a number that belongs to decimal number system. So start dividing it by 2 and write the quotient here, the remainder in the side. So when you divide 59 by 2, you can divide it 29 times, which is 58, and the remainder is 1. So quotient here, remainder by the side. Divide again 29 by 2, which is 14 times 28, and the remainder is 1. Divide 14 by 2, 7 times, remainder is 0. Divide 7 by 2, 3 times is 6 and the remainder is 2. Divide once and the remainder is 1. So start from this digit. This is very, very important. And go upwards and write it 1, 1, 1, 0, 1, 1. 1, 1, 1, 0, 1, 1 to the base 2. So 59 to the base 10 is equal to 111, 011 to the base 2. Sometimes you will have a number with a decimal point. Say for example The number may be 59.32 to the base 10. Now how will you do this kind of conversion? This 59 is the same. This is how you do it. 59 continuously divided by 2. Now this 0.32 should be continuously multiplied by 2. So how will you do this? 0.32 into 2, which is 0.64. Now take this part alone, don't worry about this. 0.64 into 2 is 1.28. Take this part alone. 0.28 into 2 is 0.56. Take this part. 0.56 into 2 is 1.12. 4 digits are more than enough. Now come from top to bottom, 0101. Take this whole number part alone. This will give you the equivalent. So the number is, this is this one, 111011 dot this number, 0101 to the base 2. So when you have a whole number and a decimal part, the whole number part should be continuously divided by 2 and the reminders alone are taken from bottom to top. And the decimal number part should be continuously multiplied by 2. Why? Because we are converting to binary number system. And continuously multiply this part alone, the decimal part alone, you have to multiply continuously and take the front part, this whole number part, 0101. So 59.32 is the equivalent. The 59.32 of decimal value is equivalent to 111011.0101. This is how you convert a decimal number to binary. The same decimal number to be converted to octal, 59.32 to the base 10. Now again take the whole number part and divide it continuously by 8. Why? Because we are going to convert to octal number system. 8 sevens are 56. The quotient is 7. 8 7 times 56. And what is the remainder? 3. Now again you got to divide this number, but this number is too small, so you can stop with this. Just one division. So the number is 73 dot, and this part, how to do this? 0.32 into 8. 8 2s are 16, 24, 25, 2.56. Now take this part alone and multiply. 0.56 into 8, which is 8, 44, 4.48. Take this part alone. 0.48 into 8, 64, 38. Then 0.84 alone into 8, which is 64, 67, 6.72. So this will go on and on and on. You can stop with 4 digits, or when you reach 0.00 at one point you can stop. So come from top to bottom, 2436. So 73.2436 to the base 8. So this is the octal equivalent of the given decimal number. So divide the whole number part by 8, multiply the decimal value part by 8 and take this front part, that is the whole number part alone. In the order you will get the octal equivalent. Now coming to hexadecimal number system, divide the numbers by 16, the same number. 59 divided by 16. 3 times. 16 3 times is 48 and the remainder is 11. Now if you remember, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 followed by A, B, C, D, E, F. So after 9 comes A. So you can consider A as number 10, B as 11, C is 12, 13, 14 and 15. So B's value is 11. So this 11 can be written as B. So the hexadecimal equivalent of 59 is 3B. Dot, you have some more numbers. This 0.32 should be multiplied by 16. So 0.32 into 16 is 5.12. Then take this part alone. 0.12 into 16, which is 1.92. Then take this part and keep on multiplying. But because it's a hexadecimal number, we can stop with 2 digits. This is more than enough. Dot 51 to the base 16. So 59.32 is a decimal number. Its hexa equivalent is 3b.51. So remember, whenever you convert a decimal number to binary or octal or hexadecimal, what is the method of conversion? Whole number part divided by 2. Decimal part multiplied by 2. Here the whole number part divided by 8 and the decimal part multiplied by 8. Here the whole number part divided by 16 and the decimal part multiplied by 16. So this is how you convert decimal number to all 3 number systems. Right? Now we'll see how to do the vice versa, from binary to decimal, octal to decimal, hexadecimal to decimal. Now we'll see how to convert binary, octal and hexadecimal numbers to decimal. How to convert all these numbers to decimal number system. Right? So we'll move step by step. First we'll go on to binary to decimal. How do you convert a binary number to a decimal number? So let me consider a number 110101 dot. We'll also have a number like this to the base 2. Now multiply the whole number part with the powers of 2. Right? So this 1 into 2 power 0. 0 into 2 power 1. 1 into 2 power 2. Next digit into 2 power 3. Next digit into 2 power 4 and so on. How many ever digits you have, that many powers you have to multiply. 2 power 5. So you have to remember the powers of 2. 2 power 0 is 1. This is 2. This is 4, 8, 16, 32. 64, 128, 256 and so on. Right? So this number multiplied by this digit. So 1 into 1 is 1. 0 into 2 is 0. 1 into 4. This 0 into 8. This 1 into 16. Then 1 into 32. Now add all this. You get 5, 21, 53. Now here comes the whole number part. Now what about the decimal number part? 0, 1, 1. Now you have to multiply this with the powers of minus powers. 2 power minus 1, 2 power minus 2, 2 power minus 3. Right? Which is, this is 0. This is equal to 0. And this is equal to 1 by 4. This is equal to 1 by 8. Add all this. So 0 plus 0.25 plus 0.125. So when you add all this, you get 0.375. So the number is 53.375 to the base 10. So continuously multiply the whole number part with the powers of 2 and the decimal number part with the minus powers of 2. And add all the products, you will get the decimal equivalent. So this is with respect to binary. So you multiply with the powers of 2. In case it is octal to decimal, you have to multiply with the powers of 8. So let us see how to do that. Octal to decimal conversion. So in this case, say for example, you have a number 137.12 to the base 8. So consider each number into 8 power 0, next digit into 8 power 1, next digit into 8 power 2. So what happens? 8 power 0 is 1. Any number to the power of 0 is 1. This is 8. This is 64. So 1 into 7 is 7. 8 into 3 is 24. And 64 into 1 is 64. Add all this. 5. 95. So the whole number part is 95. Now move on to the decimal number part. 0.12. 1 into 8 power minus 1. 2 into 8 power minus 2. Which is 1 by 8 plus 2 by 64. Because 8 power 2 is 64. So this will become 1 by 32. 1 by 8 is 0.125. 1 by 32 is 0.03125. When you do this kind of conversions, remember at least 3 digits, that is 1 by 8, 1 by 16, 1 by 32. At least 3 values you should remember. This is 0.125. This is 0.125. 1 by 16 is 0.0625. This is 0.03125. So when you keep on doing the conversions, you will remember these numbers. At least 3 you have to remember. Same way, remember 1 by 2, 1 by 4, 1 by 8, 1 by 16 at least. So that it's easy for you to do the conversions. Now add these two with 95. 95 plus 0.125 plus 0.03125. This gives you 95.15625. So this is the decimal equivalent of 137.12. So this is how you do octal to decimal number conversion. Next we'll see an example of hexadecimal to decimal conversion. Hexa to decimal. So let us consider a number, hexadecimal number, say A45.2, right? So hexadecimal should be the powers of 16. So 5 into 16 power 0, 4 into 16 power 1, A into 16 power 2. Now how do you convert A? I already told you the number for A is 10 because A comes after 9. So A stands for 10. So 16 power 0 is 1, which is equivalent to 5 into 1 is 5. 16 power 1 is 16 into 4 is 64. 16 power 2 is 256. 16 into 16 is 256 into 10 gives you 2560. So add all this, you will get 926. So 2629 is the whole number part, and for 0.2 you have to multiply 16 power minus 1. So 2 into 1 by 16, which is 1 by 8. So you know the value of 1 by 8 is 0.125. So this is the decimal equivalent of A45.2. So any hexadecimal to decimal should be multiplied by the powers of 16. So this is all about the different kinds of conversions. The easiest one being binary to octal, octal to binary. Refer to the table and use 3 bits while splitting the number. Same way, hexadecimal to binary and binary to hexadecimal will be 4 bits each. Use the hexadecimal tabular column. Then octal to hexadecimal will be in 2 steps. Convert octal to binary and then binary to hexa. So 2 steps are involved in this conversion. Same way, hexa to octal is the reverse way. Convert to binary and then to octal. Then now comes decimal parts, decimals. So when you convert a decimal number to binary or octal or hexadecimal, you have 2 things that you should do. The whole number part is divided by 2. Here it is divided by 8, here it is divided by 16. And the decimal part is multiplied by 2. Multiplied by 8, multiplied by 16. Okay, continuously do this and sum up all that, you will get the equivalent. Next comes binary to decimal, then octal to decimal, then hexadecimal to decimal. In this case, multiply by the powers of 2, multiply by the powers of 8, multiply by the powers of 16. And when it's whole number part, it is the positive values. When it goes to decimal number part, multiply by the powers, negative powers. Right? How many ever digits you have to use the negative powers and add up all this, you will get the decimal number. Okay. Hope you all understood. Thank you.